section 3.1 is power functions. Now, been talking about polynomials, and power functions are a bigger set that includes polynomials. So we're going to kind of just take a little side trip to talk about the power functions quickly, just to make sure you've got those. So a power function looks like a number and then the variable x to the n power. And your numbers c and n are real numbers. Now, some of these are polynomials, but that only happens when our n is contained in the set of positive integers. So not all power functions are polynomials, but all polynomials are power functions. So for example, you can have g of x is x to the negative 7th. That's a power function, but it's not a polynomial. You can have h of x is x to the 1/3. Again, power function, not polynomial. Or m of x is 3x squared. This is a power function, and it is also, more specifically, a polynomial. So you can use these similar techniques with that we learned with the polynomials with the power functions. So let's look at a couple of examples. Let's say we have f of x equals 1/8 x to the 4th. This is a power function that happens to also be a polynomial. We know that its domain is all real numbers because x can be anything real, and that will work out just fine. Now, the range for this particular picture is going to be y such that y is greater than or equal to 0. Now think about that for a minute and see if you can figure out why it has to be positive. Well, you probably realize that this is an even power, so no matter what number I put in for x, once I take it to the 4th power, it's going to be positive. So my range has to be greater than 0. If you graph this on your calculator, you'll see that it looks something like a big fat U. Okay, it's even, so both the tails are up. You can see that. Graph it on your calculator. All right, let's try another one. Like I say, we're just kind of looking at these briefly so that we can get a handle on this. Now here, again, it's a power function that also happens to be a polynomial, so that means its domain is all real numbers. But what is its range this time? Well, let's look at it. It does have an even power, so this one's always, the x to the 6th power is always going to be even, but I've got a negative out here, so that means in this case, everything is going to be less than 0. And if you graph it in your calculator, you'll see that this time it looks like an upside down U. Now, these are even functions. We touched on this briefly before about what an even function is. Now we're going to give it an actual definition. An even function means that if you take your function value and input a negative x instead, you're going to get the same thing for every x contained in the domain of f. So any x value that's possible for that function, if you plug in a negative x value, then you get the same thing. So let's look back up here. We have f of x is 1/8 x to the 4th. Well, if instead I try f of negative x, remember that means I'm inputting negative x into the function. So I have 1/8 and I have negative x to the 4th power. Well, if I have negative x times negative x, I get positive times negative times another negative is positive. So that's equal to 1/8 x to the 4th, which is the same thing as this, which gives me that it's an even function. Now with polynomials, if all the degrees of the terms, if every term has an even power, then the whole function is even. But if it's all mixed up, like you have x squared plus x plus 1, well, you have two terms that have even powers and one that has an odd power, so the function itself is not going to end up being even. Let's look at another way to go here. What happens if we have instead 1/8 x to the 5th? Well, in this case, it's a power function that's also a polynomial. Our domain is all real numbers. And what's our range? Well, it is also all real numbers because this 5th power means that if something's negative, it's going to be negative. This is an odd function. Now, a function can be even, it can be odd, it can also be neither. So make sure you pay attention. So we just talked about even functions. Now let's look at the odd function. What an odd function means is if you take the function and input a negative x, then you're going to get negative of what you would have if you put a positive x. And that's for every x contained in the domain of f. So for this case here, f of x equals 1/8 x to the 5th. Well, what's negative x? 1/8 negative x to the 5th. Well, if I have negative to the 5th power, that gives me, you're going to end up with a negative, because negative times negative is positive, times negative is a negative, times negative is a positive, and one more negative makes it all negative. So we can just put the negative sign out front, like this, which makes it equal to, see here, we've got 1/8 x to the 5th is f of x. So this is negative f of x. So we have our f at negative x is equal to negative f of x, which means that it is an odd function. So the way you test even or odd is plug this negative x in and see what happens. And like I said, it can be even, it can be odd, it can be neither. So let's try one more example. So here we have a power function. Now this one is not a polynomial. See here we have a rational exponent instead of a positive integer exponent. So it's a power function, but it's not a polynomial. So let's look at this. Is it even or odd? Well, that means that we figure out what f of negative x is. So we have 1/2 times negative x to the 3/2. Well, now we run into a problem. If we have a negative, this, remember, to the 1/2 power is a square root. If we're in the real plane, this isn't going to work at all. We can't have a negative x. So it's neither even nor odd. And what does that tell us about our domain and range? Well, our domain, we have to have x such that x is positive, greater than or equal to 0. Otherwise, when we take that square root, it's going to give us a problem. And then what does that tell us about our range? Well, if we're only inputting positive numbers, then our output is also only going to be positive numbers. And if you graph it, it actually looks something like this. You can graph that on your calculator and look at the picture. So power functions are a more general term than polynomials. Polynomials are power functions, but not all power functions are polynomials. You can look at any function, not just power functions, not just polynomials, any function to see if it's even or odd. And the way you do that is plug in negative x and see what happens. Remember, it can be even, it can be odd, or it can be neither. You just have to test with negative x and see what happens. So the main goal for this section is the even and odd, or neither, and just exposing you to what a power function is. Make sure you've read section 3.1 and taken some notes, and if you have any questions, make sure you have those written down for class time.